Let's deep dive into the question counting divisors from the CSES sheet, and the section is mathematics. In this question, you'll be given n integers, and your task is to report for each integer the number of its divisors. For example, if x equals to 18, the correct answer is 6. How it is? 1, 2, 3, 6, 9, 18. All are the divisor of 18. So the answer would be 6. The first line input will be given n, that is representing the number of integers, and after that there are n lines each containing an integer x, and for those integer x we have to report the number of divisors that particular integer x have. Let me make it more clear. You will be given with multiple x's, and the number of x's that you could have is q, and that will be range up to 10 to the power 5, and the value for x can go up to 10 to the power 6. Now, if you think of a brute force solution to output the number of divisors that those x's have, you can use a for loop for running each and every I up to x, and then check if that particular I is dividing x. Then just increment your counter and then print it. And you have to do this for each and every x. And the number of x's that you will have is q. So what would be the time complexity? That is qx. For each q, you have to perform this. That will go up to x. So at the worst case, it will be 10 to the power 5 and it will be 10 to the power 6. So the overall would be 10 to the power 11. So you can think of a brute force solution. So you can take reference from sieve. It's similar to sieve, in which you will be running a loop for I equals to 1, 2, you can say 10 to the power 6. Let's say n as 10 to the power 6. Now, for each and every I, you can go for the multiples. Let's say I, 2i, 3i. All these multiples have I as one of the divisors. So, if you search for all the multiples of I, let's say you are going for j equals to I to n and incrementing by I, because you want I, then 2i, 3i, so on and so forth. And then increment that divisors of that particular number, whether it would be 2i, 3i by 1. That one is I. Now, as you find the number of divisors, now you can definitely print this in a big of Q. Like for each x, you will be running a loop. Then just print that divisor of x. Just print it down. You have printed it. Now, you can say the time complexity for running these two loops. The outer loop is running for 10 to the power 6 time, and the inner one you can say it is going up to and it's 10 to the power 6. So you can say it's an n squared thing, but that is not the case if you count the number of iteration that this loops will be having. So when I equals to 1, the number of iteration that they will be contributing to, it's n by 1. Now for I equals to 2, it's n by 2. The number of multiples that 2 is having for that many iterations, now n by 3. Now how many multiples that 3 will having, it's n by 3, because you are incrementing by I only. So it's basically n by I, the number of iteration for each and every I. Now we'll be counting it. So if I take n as common, it will go up to 1 by 2 plus 1 by 3, so on and so forth, up to 1 by n. Now can you observe this as, if you reverse it, let's say if you reverse all the individual numbers, it will be 1, 2, 3 up to n. So can you see it's a arithmetic progression that the difference between each and every number is 1. So it's a arithmetic progression, but as you have reversed this, it's a harmonic progression. Now what's the difference between, for the harmonic progression, it would be 1 by the difference of the arithmetic progression. So what's the difference? It's basically 2 minus 1, it's 1. So for harmonic progression also the difference is 1. Now if you know to find the sum, it's 1 by d, then log of 2a plus 2n minus 1, where n is total number of terms, difference divided by 2a minus d. Now as d is your 1, now log of 2, what's your first term? is basically a. So 2 plus 2n minus 1, d is your 1, divide by 2 minus 1. The first term was 1 only. So what it would be? It would be 2n plus 1 divided by 1. So you can round it off to log of n only. So you had n over here also. So the overall time complexity would be n log n, because you have found the sum for this. So the sum found as log n, and you have n over here. So the multiplication lead to n log n time complexity. So you can definitely go for a n log n time complexity. So let me show the code, and I think it will be more clear. First, I have taken a count variable that will be storing the number of divisors that particular each and every x have. Now I've taken the number of integers. Then for each integer, I've taken x, and I'm printing down that count of x. That is the number of divisor that x have. Now I've calculated that particular count. I'm calling that C function. Over there, I equals to 1 to last. That last is 10 to the power 6. Now for each multiple of I, I'll increment the number of divisor. That j equals to I up to last, and I'm incrementing j by I. So I 2, I 3, I'll increment one of the divisor of all those multiples. And after that, that count is getting used for printing those divisors. That's it. I hope you like it. Thank you for watching.